Today we're going to be doing something or talking about something that you've all done before, and that is systems of equations. One of the very first methods that we learn to solve systems of equations is the substitution method. Just to give you a quick summary of that, the substitution method, the first thing we do is we solve for one of the variables, and typically what you want to do is choose one equation and solve for one variable in terms of the other variable. And make this as easy on yourself as you can. Pick one that's going to be hopefully relatively nice to work with. Choose a variable to solve for that in solving for it you don't get a bunch of fractions or something really ugly. The easier you can make this on yourself, the better. Then once we get that variable solved for, we're going to substitute, and we're going to replace that variable in the other equation with the expression that you found in step 1. We're going to substitute that into the other equation and get a new equation, and that new equation will only have one variable. Then we will just solve that equation for that variable and we'll get our answer for that variable. Once we have that, we substitute back in to the original equation and we replace the variable we just solved for with the number that we just got for it. So we substitute the value you found in step 2 back into the expression that you found in step 1, and then you can solve for the remaining variable. After you're done and you have your both values, you can always check your answer by plugging each of those values into the equations that you're working with. So quickly we'll look at a couple of examples of substitution, and then I will move on to the next method. In example 1, we're going to solve this system by substitution. So the first thing we want to do is get one of the variables by itself. Now notice, if I try and get this x by itself, I'm going to end up with a 3/4 because I'm going to eventually have to divide by 4. If I try and get this one by itself, this y, I'm going to have to divide by 3. That's going to make fractions, so I'm not going to do that one. If I divide by 2 here, I'm going to get 1/2 and a 7/2. So we want to always pick the easiest one to get by itself, and so this is going to be the y. So let's take this and solve it for y. So we'll have negative y. We're going to subtract 2x equals negative 2x plus 7. And then we'll divide by negative 1. So we're going to get y equals 2x minus 7 for that one. Once we know what y is, we're going to substitute back into the other equation. So we're going to have 4x plus 3 times y equals 4. But in place of this y, in place of that y, we're going to replace it with 2x minus 7. So now we have an equation that just has x's in it, and so we just solve it the way we normally would. We're going to distribute the 3. So that'll be 6x minus 21 equals 4. We can combine the x's. We get 10x minus 21 equals 4. Add 21, and we get 10x equals 25. So divide by 10, and we get x equals 2.5. So that's one of our answers. Once we know that x equals 2.5, we plug that right back into here. So we're going to put that back into here. So we're going to have y equals 2 times 2.5 minus 7. So y equals 5 minus 7, and y equals negative 2. So once we have those two answers, 2.5 is the x value, negative 2 is the y value, and that is the solution to our system. If you want to check them, you can always take those values and put them back into the original equations to see if they work out. Again, in example 2, we're going to solve by substitution, and in this one also, the easiest one to get by itself is this y. So we're going to subtract 3x from both sides. So negative y equals negative 3x plus 4, and then change those signs by dividing by a negative 1, and we get 3x minus 4. So that's what we have so far for the y. Then again, we want to plug that y into the other equation. So now instead of y squared here, we're going to have 3x minus 4. So this is going to take a little bit more work because we're going to get probably multiple answers in this one. So we've got x squared plus, and we need to FOIL this, 3x minus 4 times 3x minus 4. So x squared plus 9x squared minus 12x plus 16 equals 16. So this is quadratic. We want to get everything over to one side. So we're going to subtract 16, and that actually cancels out. So now we have 10x squared minus 24x equals 0. We can factor this. We can factor an x out of both of these, and actually a 2x, and that leaves 5x minus 12 equals 0. So we set each of those equal to 0 for this one, x equals 0. For this one, we add 12, and then we divide by 5, so we get 2.4. So the two x values that work are 0 and 2.4. And then we're going to plug those back in to the linear equation, the one we started with. So for the first one, we've got y equals 3 times 0 minus 4, which is negative 4. So that gives us the solution 0, negative 4. And for the second one, we're going to plug in a 2.4. 3 times 2.4 minus 4. 3 times 2.4 is 72, 7.2, I'm sorry. And then we subtract 4 and we get 3.2. So our other solution is 2.4 comma 3.2. So our two solutions, 0, negative 4, and 2.4 comma 3.2. And I know on the PowerPoint I have those as fractions. This fraction is 12 over 5, and this one would be 16 over 5.
Our first answer gives us 5 halves, comma negative 2. So x is 5 halves, y is negative 2. And for the second one, we get actually two sets of answers. 0, comma negative 4 is one of the solutions, and then 12 fifths, comma 16 fifths is the other solution. The next method that we talk about is the elimination method. And in the elimination method, we again get rid of one of the variables, but in a little different way. The first thing we want to do is adjust the coefficients. Multiply one or more of the equations by appropriate numbers so that the coefficient of one variable in one of the equations is the opposite, or is the negative, of its coefficient in the other equation. For instance, if you have 3x in one equation, if you can get negative 3x in the other one, that would be what we're talking about. Get them to be opposites so that when you, well, you'll see the next step. The next thing we do is we add these equations, and since those things are opposites, one of those variables then will cancel out. So we add the two equations to eliminate that one variable, and then we solve for the remaining variable. Again, we have to substitute back in. Once we get our answer for the first variable, we substitute back in for the second one, and then we can get the answer to the second variable as well. A couple examples of this. System shown here. Notice in the first one you have two lines, and in the second one you actually have two parabolas.
This first elimination problem is going to be pretty easy. Remember that our whole goal in elimination is to get either the x's to be exact opposites or the y's to be exact opposites. And in this case, we've already got a negative 2y and a positive 2y. So all we have to do is add these two together. We get 5x when we add 4x plus x. These cancel out to be 0, and here we get 10. So once we have that, we divide by 5, so we get x equals 2. Once we know that x equals 2, we still have to figure out y, so we plug that back in. It doesn't really matter which one, let's just go with this one. So 4 times 2 minus 2y equals 7. This gives us 8 minus 2y equals 7. So then as we solve this, we subtract 8. Negative 2y equals negative 1. We divide by a negative 2, and y equals 1/2. So our solution on this one is x equals 2, y equals 1/2. Once again, in example 4, we're using elimination. And when you have things that are squared, that's what you want to eliminate. okay, because that gives you the curve stuff. It makes things more complicated. So what we're going to do is we want to get these to be opposites. So we're going to multiply the top. We can make both of these into a 15. So we'll multiply the top by 5, we'll multiply the bottom by 3, and that's going to give us a new system, an equivalent system, which is going to be 15x squared plus 10y equals 130. And on the bottom, we're going to have negative 15x squared minus 21y equals negative 9. So once these are opposites, we can add them. So that cancels. We're going to get negative 11y equals 121. We divide by negative 11, and we get y equals negative 11. So that's the y value. We need to plug that back in. I'm just going to plug it back in here because they're smaller numbers. So 3x squared plus 2 times negative 11 equals 26. This is 3x squared minus 22 equals 26. Add 22. And that will give us 3x squared equals 48. So we divide by 3. And we get x squared equals 16. We know that we have to get this x squared by the x by itself. We take the square root of both sides and we get x equals 4. But we have to remember, anytime we take the square root of both sides of an equation, we have to put in plus or minus. So x could be positive 4 or negative 4 when y is negative 11. So our answers are 4, negative 11, and also negative 4, negative 11. So we have two solutions. And if you think about it, these are both parabolas, so it's very possible that they intersect more than one time. And in this case, if you think about the graph, they intersect twice.
The answer to example 3 is 2 comma 1/2. And then we again get two answers in example 4, and this is negative 4 comma negative 11 and positive 4 comma negative 11. One other method that we use sometimes if we don't need an exact answer is a graphical method. And so when we do this, we graph each equation. And the first thing we have to do is express each equation in a form suitable for the graphing calculator by solving for y as a function of x. And then we graph each of the equations on the same screen. We then want to find the intersection points. The solutions are the x and y coordinates of the points of intersection. So we use the graphing calculator to show those points of intersection using the intersect feature on the calculator. So here are a couple of examples to solve by graphing. If you see, the first one is a parabola and a line. The second set of equations is one is a circle and the other one is a parabola. So we'll see how those work when we find their solutions. In this problem, we're going to be solving by graphing, and we're going to enter these two equations. So first of all, on your calculator, you're going to go to the y equals key, and we need to enter these in as we have solved them for y. So if you think about it, we would have to add y to both sides and subtract 2. So y is going to equal, for this first one, x squared minus 2. And then we can go down to the second equation. If you think about getting the y by itself here, again we'll have to add y and add 1. So for that one we'll have y equals 2x plus 1. Once we have that, it's a good idea, especially if you are using a calculator that other people use, is we push zoom and we go down to number 6 for a standard screen. So we'll hit enter. And so notice the first one is a parabola, the second one is a line, and we can see that it intersects in two spots, once here and once here. So we want to find those x and y coordinates, so we're going to go to find the intersection. We push second and trace. So second, trace, that will bring us to this screen, and we're going to go down here to number 5 for the intersect feature. We hit enter. And notice it's going to ask us for the first curve. So what we do is we go over by one of the intersections. We don't have to be that close to it, but just by it. We hit enter. It goes down to the second curve. We hit enter again. It asks us if we want to guess, and we don't want to guess, so we just hit enter a third time, and notice that it will find this intersection. And so one of our values for intersection is -1, -1. So one solution is when x is -1 and y is -1. To find the second solution up here where they intersect, we're going to do the same thing. Second, trace, go down to intersect. Only this time we're going to go over by the other intersection point using our right arrow. And again, all we have to do is hit enter 3 times in this feature. So enter, it goes to the second curve, enter, it asks us to guess, we push enter, and it finds the answer. So the second answer is when x is 3 and y is 7. So right there we can see our answer, and looking at that, -1, -1, and 3, 7. To solve example example 6 by graphing, that one's a little bit more difficult, at least the first part is. We've got to get the y by itself again, so we have to subtract y squared and subtract 12, but then we have to take the square root of both sides. And just like we mentioned in an earlier problem, when we take the square root of both sides, we have to have a positive and a negative answer. So here's what we're going to get. We're going to have the square root of x squared minus 12 as one of our, that's actually half of that equation, but then we have the opposite, the negative of the square root of x squared minus 12. Once we have that, that's the first equation right here. Then the second equation we can just type in. So 2x squared minus 5x. And we hit enter. We don't even need to hit enter. We just go graph. And notice we get that shape. And so that is the initial something's wrong here. Oh, this is what happens when I do them in my head. Okay, we have to subtract y. Actually, we're going to just subtract the x squared. So what happens here is we subtract x squared and then take the square root of that. We're going to have 12 minus x squared. And down here, also 12 minus x squared. So we still need the plus or minus, but we need to have the right values inside of there. So now when we look at the graph, this should have been a circle. That's why I stopped right away. And again, our screen is oblong, so that's why it doesn't look exactly like a circle. But we can see that it looks like it probably intersects in 3 spots. So let's find these first couple. We'll go second trace, down to intersect. And notice I'm already close to this one, so I'm just going to hit enter. But notice it jumps to this bottom curve, and that's not what I want. So I use the up and down arrows to go to the parabola. So I hit enter again, and now it will find the intersection of those two values, or those two things. And we get one intersection is -0.56, and the other one is 3.42. To find the one over here on the right, we do the same thing. Second trace, go down to intersect. And we're going to go over to the right and get close to that one. So we hit enter. But again, notice it jumps to the wrong one, so we're going to push our down arrow and follow that parabola. We hit enter again and enter a third time. And our second answer is 2.85 and 1.97 for x and y. Now this last point down here, let's see what we can do. We want to go second trace, intersect. This time I'm not using that top part of the circle, so I have to push my arrow to go down to the bottom part of the circle. And notice it will only intersect there one time. So we hit enter, and then we go to the parabola, which we're on, so we hit enter again, and enter a third time. And we wait, and we wait, And now we get an error message that says no sign change. Let's go back to this, look at our graph. And it looks like it intersects there, but let's zoom in and see. So we're going to hit our zoom key, and we're going to go down to zoom in. And notice we can move our cursor from where it was down close to where this looks like it intersects. So if we hit enter, there's the bottom part of our circle. And here's our parabola. It still looks like it intersects. So notice my cursor is still here. I can just stay there and I can hit enter again. So there's another piece of our circle. And okay, now after we zoom in a couple times, we see right here, that's why we had this error message. They don't ever intersect at the bottom. So our only solutions there are, and I rounded them off differently, but negative 0.6, comma 3.4, and 2.8, comma 2. For the first one, we get negative 1, comma negative 1, and then we get 3, comma 7, so there are two solutions there. In the second one, we also get two solutions, negative 0.6, comma 3.4, and 2.8, comma 2. So in both of those, we end up getting two equations, or two solutions. Our assignment for tonight is assignment 34, section 6.1, and you can see the numbers there. Again, practice some of these so that you are prepared for our test when that comes up, because that will be coming this is a very short section, so that'll be coming up very quickly.